Hi and welcome to my channel. If you're new here, just as a summary, I'm going through the GCSE Edexcel Maths Higher 91 syllabus. You can also use my videos if you are doing the foundation as well. I will try to define which videos are specifically for the higher syllabus students and for the foundation syllabus students. So in this video, this is video 2.6, algebraic fractions. Before we start, if you do not know what a fraction is or how to use them, please do check my videos on fractions. You can find it in my channel and it will be under the GCSE 91 full syllabus course content. So let's start this off. So first of all, we're going to be going through the difference between normal fraction and an algebraic one. So the first thing you need to know is they are the same. There is pretty much no difference between a normal fraction and an algebraic fraction. Some people always think a fraction is different to an algebraic fraction, but there is no difference at all. So like a normal fraction, it has the normal features. In here we have the numerator on top and the denominator on bottom. So here's an example of what a normal fraction looks like. So this is 4/5, or in other words, it is 4/5. So, and this is what a algebraic fraction looks like. So here we have x plus 2 over 2x minus 3. So when you're looking at both of these, don't get intimidated by it because both of these show a fraction regardless of what they look like. So don't get confused by this, because most of the time people always get confused when they get intimidated when they see this algebraic fraction. So now we know what an algebraic fraction looks like, and we need to understand how to actually deal with the algebraic fractions. So when dealing with the algebraic fractions, it is easier to consider the numerator and denominator as separate expressions, because I have seen many people try to think this is a whole thing as one expression, and they end up not understanding the whole topic because of that reason. So what I mean by this is, so in this fraction over here we have x plus 2 over 2x minus 3. So this is the numerator and this is the denominator on bottom. So what I've seen most people do is they consider this whole thing, the numerator and the denominator, as one expression. But in reality, it is so much easier for you to just consider this thing as one expression and this thing as the second expression. And it will be so much easier going through that. So let's move forward. So consider a numerator and denominator as separate expressions. So as you can remember in my previous videos on fraction, we discussed about the lowest common multiple and the prime factor decomposition. This still applies for the algebraic fractions, but it will be a little different. So instead of using the lowest common multiple and the highest common factor, we will use factorization, because this will allow us to cancel out factors that will make the fractions that will simplify the fraction to a smaller fraction. So with this being said, you do not always get something that can factorize or that can factorize and cancel down after being factorized. So there are two main factorizing methods. So the first is the common factor. This can be found in my factorizing part 1 video. The second way is the full factorizing method. This can be found in the factorizing part 2 video. So in the full factorizing method, you have another two methods to do it. So the first one is the adding up the factors of the constant to get the middle number, or the other one is the box method. So whichever one is best for you, you can choose. So if you're not sure about that, you can also visit these videos in my channel. So finally, you need to be able to expand out the brackets and to simplify these expressions. So if you're unsure of any of these, I highly recommend you just review my previous videos and just get into a recap of what these expressions mean. So keeping this in mind, let's see how we're going to actually apply this knowledge into algebraic fractions. So first of all, we're going to go into simplifying fractions. So in my previous video, in the fractions video, I talked about simplifying fractions. So just as a small summary, simplifying fractions is basically you're getting a big fraction, so it's big number over a big number, and you cut it down into a smaller number. So it's much easier to see and much easier to understand, and less likely to make a mistake throughout when you're doing other calculations. But bearing in mind that both of these fractions, so the one with the big numbers, so that's a non-simplified version, and the simplified version, at both of them, they give the same decimal place. So both of them, they give the same value when you actually divide it out. So if you get different values, then you've done the fraction wrong. You simplified it wrong. If you get the same value, you know you did it right. So these are the steps you need to follow. First of all, start with the numerator. I mean, technically speaking, you don't actually need to start with the numerator. You can start with the denominator first or numerator, whichever is easier. For me, I think the best thing to do is always start with the numerator. Then, this is step 1 is starting with the numerator. Step 1.1, you need to ask these questions when you're doing these, when you're doing a calculation question, you need to ask these small questions in your head. It's almost like a checklist. So can you factorize the numerator by taking a common factor out? If you can, do it. If not, don't worry about it. Second question you need to ask is, can you factorize it by the full factorizing method? If you can do it, then go ahead and do it. If you can't, then just review the questions, see if you can't actually do it. And if you can't do it, then that's fine, leave it as it is. So sometimes this can be a little confusing to some people, because what they do is they try to go to full factorizing, but they don't take out the common factor. Excuse me. So sometimes what questions do is they, just to throw you off, they put big numbers into a quadratic expressions. When you put a big number into quadratic expressions, most people, they get confused because it's actually harder to actually solve those questions. But you need to remember is, can you factorize it by taking a common factor out first? Once you took the common factor out, then it can be easier to factorize. So it can be an easier question. So once you've factorized it, then you can just multiply in the common factor at the end. So let's take a look at that in a later video, but let's keep moving forward in the simplifying fractions. So after you've asked this question, you need to move into the second step, which is repeat step 1 for the denominator. Now, if you've done step 1 for the denominator, then step 2 would be repeat step 1 for the numerator. So in here, in step 1 and step 2, what it does is it just what we did in the previous in the fractions video, what we did was we broke the fraction down into its lowest prime factor decomposition, and then we just cancelled everything together. So the same way, that's what we're going to do here. Now, step 3 is cancel out the factors from the numerator and denominator. So to find the factors, that's why we are factorizing in the first place. So using the factors, we just cancel it out, and then once you've done that, simplify. So what I mean by simplifying is, once you've crossed out the factors that are there, what you need to do is you're just going to write the same thing again, but with the factors that are left over. So let's look at an example. So example 1, simplifying. So this is 2x plus 4 over 6x minus 12. So if you want to have a go at this question by yourself, then you're more than happy to pause the video and have a go at yourself. If not, let's move forward. So first things first, you need to factorize the numerator or denominator, whichever one you choose, you can choose. But for me, the easiest way is to go from top to bottom. So I'm going to choose numerator. So factorize the numerator. If you see it, 2x plus 4, that's the numerator. Well, you can see that 2 is a common factor, so I'm going to take out 2. So yeah, so this clearly shows that here 2x, when you break it down to factors, it becomes 2 multiplied by x, and 4 becomes 2 multiplied by 2. And as you can see, 2 is a common factor, so you take out the 2, you put the rest in brackets. Now you do the same for the denominator. So this is 6x minus 12. So when we break it down, it becomes 6 multiplied by x and then minus 6 multiplied by 2. As you can see here, the 6 is a common factor, so we take out the 6. Now 3, simplifying. So in the steps that I told you before, I said 3 was cancelling out, but here I said simplifying. Technically speaking, both are the same thing, because it's just you're cleaning things up. That's what I mean to say, because like you've done your job and you're cleaning it out. That's what you mean by simplifying. It's the final product. So you write it as a normal fraction first, then you write out the factorized fraction. Then what you do is you need to cancel it out. So you're going to cancel both the numerator and denominator by 2, because that's the highest common factor both of these numbers have in common. So 2 divided by 2 becomes 1, and 6 divided by 2 becomes 3. Now you're just left with x plus 2 over 3 bracket x minus 2. You can leave it as this, or sometimes you can leave it, you can expand out this bracket and leave it like that. Let's take another example, simplifying. So this is a little trickier example of the last one, but let's tackle it one by one. So same as before, we were factorizing the numerator. So numerator is this. So first we look at is, can we take a common factor out? In reality, in this one, no. It's because the coefficient of this is 1, the coefficient of 3 is, this is 3, and the constant is 2. So it doesn't have anything in common, so we cannot take a common factor out. But what we can do is, we know the full factorizing method, so we take the factors of 2. So the factors of 2 are 1 and 2, or minus 1 and minus 2. Since we need 3 over here, positive 3, we're going to use 1 and 2. So we know that 1 plus 2 is 3. So we're going to use those factors. So using these factors, we know the factorized form is x plus 2, bracket close, bracket open, bracket open, x plus 1, bracket close, bracket open, x plus 2. So this is the factorized numerator. Now we do the same. So I'm just going to put the question here up again. So we're going to do the same, but for the denominator. So factorize denominator, and this is the denominator. Same as before, we check if there is any common factors that we can take out. As you can see, there is nothing you can take out, because none of these have anything in common. Now we're going to find the factors of 10. So the factors of 10 are 1 and 10, or minus 1 and minus 10. And the other one is 2 and 5, or minus 2 and minus 5. Since this is minus, since this is minus 10, one of these must be minus. So it means either minus 1 multiplied by 10, or 1 multiplied by minus 10. Or it's minus 2 multiplied by 5, or it's 2 multiplied by minus 5. So we need to find a factor that comes into minus 3. So you need to be a little smart about this thing. So whichever it is, so whichever is minus, this, when you subtract one from the other, this will always be 9 or negative 9. However, this one, it will be 3 or minus 3. So you need to be a little smart about this. You don't need to list everything out and then minus and subtract and all that stuff, but you just need to be a little smart about which ones you actually choose. So since we know what we're going to do, we're going to remove this and we're going to stick with this one. So it's minus 2 plus 5 is 3, positive 3. Or if we have minus 5 plus 2, that's negative 3. So when comparing these values to this value, what we need is negative 3. So these are the factors that we're going to use. So using these factors, we know that the full factorized form is x plus 2 and then x minus 5. These are the full factorized brackets. Now, we need to simplify it. So when simplifying, I always tend to write down the full fraction that I always begin with, because it's much clearer to the examiner that you know what you're doing, and it's clearly setting out that this is the answer to the examiner. And using this way is quite a neat and clean method. So, writing the factor form now, and then as we can see, x plus 2 and x plus 2 on top, and there's a x plus 2 on bottom. Now you can actually cancel these two out. Now we clean it a little further. So now we're left over with x plus 1 over x minus 5. So this is the question. This is the fully simplified fraction of this big fraction. So this is the starting fraction, this is the simplified ending fraction. Right, so let's move forward. So adding fractions. So same as before when you're doing just normal addition in fractions, we're gonna do the same thing for these algebraic fractions. So the steps are as follows. 1. Make sure both fractions are to its simplest form. So before you start doing anything, make sure both of these fractions are to its simplest form. If there's anything, common factor, you take it out. If there's anything else, you just take it out. You cancel it and do your thing with it. And step 2, factorize the denominator using common factor method, or factorize using the main factor method. So remember, for this one, I specifically said denominator. You're not going to touch the numerator yet. So denominator. See what factors are the same and different in the denominators, and make the denominator the same. So remember, when you're adding fractions, you have two denominators. So one from the first fraction and second one from the second fraction. So those are the two denominators, and you're comparing those two denominators. You're not comparing the numerators yet. Now, once you made the denominators the same, do the same thing to the respective fraction. So when I say fraction, I mean include the numerator as well. Now add both the numerators once the denominators are same, and simplify. So let's look at an example of adding. So this example 3, adding. If you want to pause this video, you're more than happy. I'm more than happy for you to do so. And if you want to continue, let's go forward. So when looking at the denominators, we're going to first we're going to simplify. I'm getting confused now. So first we're going to simplify both of these fractions. So let's take a look at this. So for this fraction is already in its simplest form. You can't do anything further with it. There's no common factors or nothing there, so don't need to worry about it. But this one is actually not in its simplest form. As you can see in the denominator, you can actually take a 2 out as a common factor. And let's take it out. So we can take a 2 out as a common factor, and we know that 2 and 4, they are multiples of each other. So we can actually cancel it out. So we can cancel out the 2, so divide 2 from both top and bottom. So when you divide 2 from the bottom, you're left with 1. When you divide 2 by on the top, you're left with 2. So the simplest fraction is 2 over x plus 1. Now, so this is what we have now. So we know that, as you can see, the first fraction, the denominator is the same, and the second fraction, the denominator is the same as the first fraction. So you just need to add everything together. You're just reviewing it. So as you can remember, you don't, when these two denominators are the same, you don't do anything with it. You just put it underneath here, and then you just add the numerators up. So you're left with 5 over x plus 1. So this is the answer. So let's look at another example. So this one, example 4, adding. Okay, so we're gonna actually add x plus 1 over x plus 2 plus x plus 2 over x minus 5. So first is, both are simplified. So you need to check if there's any common factors to take out. Since there is nothing, they're simplified. So secondly, you need to see if it can be factorized further. Well, in this case, it cannot be factorized further. Now, we need to see and make it the same denominator. So as you can see, the denominators, they can't be factors of it. They cannot be factorized, so there's no factors. Therefore, it must be the lowest common multiple. So the lowest common multiple is just both of them multiplied together, because there's no actual multiplication table for x plus 2 and x minus 5. So the only thing is, you can do is just multiply both of them together. That will give you the lowest common multiple for that for this. Now, once you've made the lowest common multiple, do the same for the numerator. So this is the first fraction. So the lowest common multiple of the denominator is x plus 2 bracket x minus 5 bracket. So since you're multiplying x minus 5 on bottom, you need to do the same for the top, and you multiply x minus 5 on top. Then you move on to the second fraction. The second fraction is basically, you write down the fraction like this. So on top you can see, so it's x plus 2 over x minus 5. That's this fraction. Now, to make the denominators the same, what you need to do is you need to multiply by this. So x plus 2. Since you've multiplied the denominator by x plus 2, you need to do the same for the numerator. So multiply that by x plus 2. So note here that I actually use both of these the other way around. So x plus 2 multiplied by x minus 5, and over here x minus 5 multiplied by x plus 2. Well, this is the same as saying 4 multiplied by 5. So these are the same thing. So it's a little bit like saying 4 multiplied by 5, it gives you 20. But 5 multiplied by 4, it still gives you 20. So this in maths is actually called the commutativity. So this is just saying that when two numbers are being multiplied together, it doesn't matter which order they're being multiplied together by, they will still give you the same answer. So it's the same thing for me to write down this x plus 2 on front or x plus 2 on behind, it doesn't really matter. Now fifth step is to simplify. So what I'm going to do is I'm just going to expand out these two brackets, and we're going to put it here, and we're going to expand out these two brackets, and we're going to put it here. And then we're going to expand out these two, and I'm going to put it here. As you remember in the fractions, when you're adding, when you made the denominator the same, the denominator don't get added twice. You just use that same denominator down here. Now you've expanded out the brackets, what we're going to do is we're going to cancel things out. So we have minus 4 on top and plus 4 on the other. So on the numerator we have minus 4 and plus 4. That's going to cancel out. So we're going to leave that. Now we're going to simplify further. So x squared plus x squared, that's going to give us 2x squared. And then minus 5 plus 4, that's going to give us minus 1. So we're going to be left with 2x squared minus 1 over x squared minus 3x minus 10. Now subtracting fractions. This is going to be the same thing as adding fractions, but instead of adding fractions, you just subtract fractions. So it's going to be pretty much the same steps, so let's go through it quickly. Make sure both fractions are simplest form. Factorize using common factor method or the main factor method. See what factors are the same with the denominator and make the denominator the same. Do what you did to the denominator to the numerator, and it must be said subtracting both numbers together and simplify. So multiplication. Multiplication is the easiest thing, same as before. You just multiply the numerators, then multiply the denominators, and you simplify. As easy as that, it's the easiest one out there. So let's take an example. So example 5 multiplication. So we have 1 over 5x minus 3 multiplied by 4x plus 9 over 3. So we take the numerators. So it's 1 multiplied by 4x plus 9. So 1 multiplied by 4x is 4x and 1 multiplied by 9 is 9. Now we look at the denominators. Denominators is 3 multiplied by 5x minus 3, which is going to be 3 times 5 and 3 times 5x, that's 15x, and then 3 times minus 3 is 9, minus 9. Now we simplify it. Simplify means putting it on one top of the other. When we do that, it becomes this: 4x plus 9 over 15x minus 9. As you can see, on the top you can't take any common factors out. On the bottom you can actually take a 3 out, but there's no much use because the 3 doesn't actually get cancelled out. So you just leave it as it is. Let's look at another example. So in here you have 12x plus 2 over 5x minus 3 multiplied by 10x plus 3 over 2x plus 2. First thing you need to do is, same as before, factorize. So this first one, you can take a 2 out, so it's going to become 2 and then bracket 6x plus 1 over 5x minus 3. Do the same thing for the second fraction. So first thing, 10x plus 3 is not going to change, and 2x plus 2 is going to change into 2, and then x plus 1. You can cancel out these 2's together because they are the same, or factors of each other, so you can cancel those 2 out. Now you just simplify it. Now you do 6x plus 1 multiplied by 10x plus 3, and on bottom you multiply the bottom across as well, which you can simplify down into, or expand the bracket into, and you can expand the bracket into that one as well. So the numerator is going to be 6x squared plus 18x plus 10x plus 3, which can be simplified down into 60x squared plus 28x plus 3. Now when we look at the denominator, we can do 5x multiplied by x, that's 5x squared, and then 5x multiplied by 1, that's 5x, and then minus 3x multiplied by x is minus 3x, and minus 3 multiplied by 1 is minus 3. Simplify that down further, so it's 5x squared plus 2x minus 3. Now when we put it into a fraction, it becomes this. So as you can see here, you can't actually take a simpler fraction as more than this, because you cannot factorize it further down and cancel anything down with it. So this is the answer. Now division. So division is a different one. So when I say division is a different one, I mean you're using the same concept as before, but the only difference is, because people just tend to mess this up a lot. So just do a small reminder. So KFC, hope you remember this. So KFC is keep the first, flip the second, change the sign. Just follow this. This is the most simplest step anyone can remember and do. So let's take an example. So we have KFC here. So first of all, we're going to keep this. So keep the first, x plus 1 over x minus 3, and then flip the second, which is going to be 2x minus 1 over 4. Now change the sign. Now what you do is you multiply it. So numerators are going to be multiplied and denominators are going to be multiplied. Now it's just going to be simple multiplication of fractions. Now you're going to expand out the brackets. So it's going to be 2x squared plus x minus 1 over 4x minus 12. So this is the answer that you get for this fraction. And the same way, let's look at another example. So x plus 1 over minus 4x, and it's going to be keep the first and flip the second and change the sign. The sign is there. Since both the top and the bottom it has x plus 1, we're going to cancel that down. Now we're just left with 1 multiplied by x plus 4 and 1 multiplied by x minus 4. When we simplify that, it's going to be x plus 4 and x minus 4. So this is what it is. So don't get confused about these fractions, guys, but it's just actually pretty simple and pretty straightforward. If you know how to do these questions, basic addition, multiplication, subtraction, and division questions in the fractions, then algebraic fractions, they are the same thing. It's much easier than normal fractions because you have less things to worry about. I mean, it's a little longer, so you need to when I say it's a little long, because you have the x and then the constants and variables and all that jazz, but other than that, it's much easier than a normal fraction, especially once you get used to it. So summary, in this video you have learned the following. What is an algebraic fraction? Difference between an algebraic and normal fraction, simplifying fractions, basic operations with fractions. So that is addition, subtraction, multiplication, and division. So thank you for listening, and I really hope you enjoyed this video. And if you did, please like the video and subscribe. If you also know anyone who is in trouble or need help in maths, please let others know of this channel if you found this helpful. And please leave your comments below. If you want me to go through anything, then please do leave a comment on that as well. And if it's your first time here, make sure you check out my playlist on the GCSE 91 full course content in my channel. And thank you for listening. I will see you next time.